Usually I will suggest you to complete the square. Don't ask any question when it comes to function, just complete the square for fx. Because even if you don't use it for the first part, the subsequent part you need it. So I'm just gonna let this is x plus 3 over 2. I get very uneasy when I see a quadratic expression without completed the square. Okay, you should develop that kind of intuition, like that kind of instinct. Then you just, yeah. X power 4 is x plus 3 over 2 squared. Then what you do is actually just draw. 3 over 2 less than negative 3 over 2. So this would be mean point, negative 3 over 2, negative 5 over 4. So negative 3 over 2 is here. Negative 5 over 4 is here. Bring it up. Great. I just want to have a sense of what is going on here. I usually just draw the graph. So using since horizontal line y equals to a, cuts f at most once. Hence, f is 1, 1. Thus, f inverse exists. Okay. Go. A lot of times, you need to know what is like all these horizontal asymptote, all these, you need to know, because the GC won't tell you that this actually has a horizontal asymptote of y equals to 3. Okay? So you need to know that. So when you sketch a graph here, just use the GC and plot it out. This one here. So it'd be like that. Part 2, horizontal asymptote is y equals to 3. X. Okay, great. It's really okay. Give a reason why the composite function exists. F inverse G. So we need to show that range of G contains in the domain of F inverse. Okay. Remember the Archer situation. The first guy is G. I always say the first and the second guy. So this is the first. This is the second guy. The first range had to be in the domain of a second guy. Just remember that. Okay. If you know that, it's much easier. Yeah. So you will get G. The range of G you have, right? The range of G is actually 3 to infinity. The domain of F inverse is a range of f, which is actually from minus 5 over 4 to infinity. So since range of G can be contained in a domain of F inverse, hence F. Okay. There you go. I think the subsequent is okay lah. Aiyo. Why? The subsequent one should be okay. I will just quickly do the subsequent one. I want to rush through the last part. State the domain of. Okay. Find F inverse G. F inverse GX. Aiyo. FIFO. This is what, man? You need to find F inverse first. Aiyo. Okay, let's find F inverse first. That's why it's 6 marks. So let okay. Yeah. Find F inverse X first. F inverse function first. Then you substitute in. I think it's pretty okay. So this part here, part 2. F inverse GX. This is F inverse G, which is three plus E minus X. 3 plus E minus X. Negative 3 over 2. 3 plus E minus X plus 5 over 4. Yep. There you go. Then once this is done, find GX. Domain of G, F inverse G is just domain of G. First function decides who go in. Oh, just it? Yeah, okay. I see. Part 3. Part 3, I don't know. It's a bit of stuff. Okay, that's why sketching the graph is important. First of all, you try and understand what's going on here. I will sketch this graph, definitely. So what is the vertical asymptote here? Ln has got vertical asymptote. This vertical asymptote here is x equals to k minus 1. Any issue there? No. So k minus 1. Now, when you sketch this graph here, hx, I don't care how you sketch it out, but when you sketch this graph here, you know that it has a vertical asymptote of k minus 1. And you're sketching from k, when it's k that time is 1, so it goes up from here. 0 that time is 0 is 1. Ln 1 is 0. Ln 1 is 0. Okay, good. So this is, it looks like that. I'm just going to quickly go through this. This is where you start from k, right? K is here. This is when it's 0. This is ln 1 minus k. You can quickly do this by just substituting all the values in. Okay. So actually, I don't really need the vertical asymptote because I sketch from k. Okay, where k is less than k is less than 0. So what I drew was correct. K is less than 0. So can you imagine this cherry bomb here? This ln graph here is just like that. Meaning, just move to the depending on k is negative, so this graph will look like that, exactly like that. Okay, so that's pretty okay. Then you're told to find a value of k such that the range of hg, so this is hg, right, is given by ln 5 to infinity. So the range of hg is ln 5 to infinity. Jalat, this one. Okay, understand this? I'm going to go through this. It's going to be a bit confusing, really. Try this. Ln 5 to infinity, meaning who's the second function here? Second function is h, right? So in other words, you are looking at ln 5 to infinity. Can you draw ln 5 to infinity here? Ln 5 will be, ln 5 is here, to infinity is here. Okay, means that whatever I do, right, I want to chop off my ln 5 here. So here is my ln 5 to infinity. Means whatever I fit into this h here, this one will be from range of g. Mapping, right? Whatever I fit into this second function h here, I need to make sure that it produces a ln 5 to infinity here. This is ln 5 to infinity. And it's not equals to, so it's empty. It's going to be confusing, I understand, but just bear with me. This part here is pretty good. Okay? Find the value of k. Okay, great. It means we can find the value of k because that is ln 5. Ln 5 to infinity. Yeah, actually you got it already. Oh, that's it. Oh, that's the k value. You can solve already, right? X. Value of k. Yeah, that's about it. So you just, this is 5. This is 5, ln 5. Ln 5 equals to x. Oh, yeah, okay. So this part here, if I do the difference, right, this will be ln 5, meaning the x value. Okay, I find what's the x value here, people. Oh yeah, it's not really that. Okay, so this is 5 equals to x minus k plus 1. So x is equals to 4 plus k. Any issue that? This part here is ln 5, right? This is ln 5, right? So if you let side working, so ln 5 equals to ln x minus k plus 1. So x is equals to 5 is equals to x minus k plus 1. So x is equals to 4 plus k. So this is 4 plus k. Yeah, this will register a 4 plus k here. Yeah, that is okay. This is 4 plus k. Yeah. Then this will be 4 plus k, right? Then you go back to your G graph, which is here. So this one will be 4 plus k to infinity. Because this, whatever happens, you're actually feeding 3 to infinity inside the second graph. Or actually, you can just put here as 3 to infinity. Then you can just compare this 4 plus k and 3 together. So 3 equals to 4 plus k. K is equals to -1. Okay? I repeat, this is mapping function. So what I did was actually, I take from 3 to infinity, from this graph here, this is 3 to infinity. This one I know confirm plus chop will fit into the second graph one, for the range, the second graph of YIJC. Okay? So I work backwards. So actually this one here, I compare with the 4 plus k. So 4 plus k equals to 3. So 4 plus k equals to 3. So k equals to -1. So the answer is k equals to -1. It's mapping. That's why I like to use the graph. You use graph, it won't go wrong one. Okay. I know there are many methods to find the range of composite function. I totally understand. But I have always been a strong advocate of graph, because if you